Hello students. In our final lesson in the module on Python for AI, we will look at a package called SciPy, which is short form for Scientific Python. Now I'm showing the web page out here. Once again, we will go through mainly the web page for a little bit because it's mainly function calls and so on here. As you can see on the website out here, SciPy has different packages inside it, and as the name says, scientific computations. So I will highlight a few, but we will delve a little bit into one of those. So for example, here SciPy adopt FFTT. This is the fast Fourier transform package, and you can see there are different implementations of fast Fourier transform algorithms that are given. Once again, as you can guess, we will not need all of these, or much of these we will not need for the AI course. Now, one of the SciPy packages that I find very useful is the linear algebra one. Okay. So in the linear algebra, we will use different functions in order to fit data, in order to calculate regressions or best fit among lines. And there are many functions inside this SciPy linalg package which support that. For example, one of the ones that's widely used, that I use a lot, is basically this norm, which is finding the matrix or vector norm. So that comes in very handy while finding the Euclidean distance between two pairs of points in an n-dimensional space. Okay. Within the linear algebra package, again, there are different matrix operations as well. So for example, you can find eigenvalues of matrices or arrays. There are different matrix functions as well, like doing trigonometric functions on matrices, solving matrix equations, Lyapunov functions, and so on. So basically, unlike in olden days, you would have to implement all of these, or you would have to find external programs to solve this. But this package basically provides the implementations of all of this. You can just import scipy.linalg and you can use the appropriate algorithms from here, passing the data that you have. Okay. There are different other packages here as well. So there's one for high dimensional image processing, n-dimensional image processing called ndimage. There are signal processing packages as well. Many of these we will not require for the AI course, but just for your information, if you need something in a project or in an assignment, these are there. Finally, one of the things that I use from SciPy is this constant package, and different physics constants like the value of the gravitational force of Earth, G, standard acceleration G, gravitational constant, speed of light, epsilon, and so on. These are different logarithmic constant, physics constants. These are provided. Okay. So once again, these can also be used as required in your program. So once again, SciPy, it's a useful package if you are implementing scientific algorithms. As I was saying before, for Python algorithms, before implementing something on your own, make sure to check that something might be there in the standard packages. So it's a good idea to reuse those because they are written with efficiency of code and time in mind. So that brings us to the end of this module, Python for AI. In this, we mainly looked at three Python packages which are useful for AI. NumPy, which is used to provide array implementations. Then we looked at pandas for data frames, basically row column type things and how to do different operations with them. And finally, we looked at very briefly at scientific Python, which is implementation of scientific algorithms within Python. So that brings us to the end of the overview of Python. We had two modules on this. From our next module, we will go back into AI and we will continue discussion with different search algorithms.